Okay, lesson number 10, part 2. Let's look at some things that we didn't cover in the first video. Sometimes you're going to see a piecewise function that doesn't have an answer. So for this one, it's asking us to find the value of the function when x is equal to 2. Yet when we go over to here, we're like, wait a minute, x is less than 1, right? That's not 2. X is greater than 4. Well, that's not 2. So it looks like if we were to graph this, there would be no value for when when x is equal to 2. So we would write undefined. So I know that you saw that in Delta Math, and probably that was very unsatisfying. And that is the way it is because some piecewise functions will just have big gaps in their graph. Another type that you may see on Delta Math is this, where it says when x is any number, like this right here, really we can read it as, x not equal to 4 means, well, when x is any other number besides 4, you're going to use this linear equation, right, to make your graph. Okay, that was annoying. But when x is equal to 4, it has a value of 3. And so what does that 3 mean? It means that y is equal to 3 at that point. So when they ask you to find the value of the function when x is equal to 4, we're like, all right, this one pretty much says it all, that y is equal to 3 when x is equal to 4. So we would write equals, once again, I'm not, that was a strange equal 3. Just trying to use my finger to write. It's not, my finger's not that talented. All right. Oh, and here's the graph of what we were just looking at. It would look like the line 2x minus 2, but there'd be a hole right there. When x is equal to 4, there's a hole in the graph because that line does not represent the value for when x is equal to 4. And then that dot at 3, y equals 3, is the value for when x is equal to 4. All right, what else are you going to see on Delta Math? You might see a piecewise that has 3 parts to it. This one looks like when x is greater than or equal to 0 and less than 5. If we looked at the graph, we're going to see a line. The equation of the line would be 2x minus 6. When x is equal to 5, we're just going to see a point at where y is equal to negative 1, or that point would be 5 comma negative 1. And over here, when x is greater than 5, if we saw the graph, we would see a quadratic that was flipped, right, because that negative. So finding f of 5 is just saying, hey, what's the value of y when x is equal to 5? Well, here it clearly tells us when x is 5, the value of y is equal to negative 1. So let me try writing again. So we would have negative 1 here. So this is just about, I think the Delta Math problems are really about looking at this side to see where the x that they're giving us falls. And then once we figure that out, using the rule from this side to find our value of y, or the value of the function at that certain x. All right, let's try another one. I think I'm getting better at this using my finger on the touchpad. All right, so this one says find f of 2. So first, our first job is to decide, well, where does 2 fall? It's going to fall with this, right, with these parameters. So x is stuck between, it looks like it's greater than negative 3, but it's less than or equal to 2. So we know we're going to use, because those are the parameters of where 2 fits in, that means that we're going to go ahead and use this rule. And so that just means we're going to plug in 2 when we see x. Oh, all these 2's. All right, so let's plug in 2 when we see x. We'll have negative 2 times 2 is negative 4. Negative 4 minus 2 is negative 6. All right, let's see what else I have on here. All right, so let's see what's behind here. All right, so there's a graph, and they're asking me to find f of 4. So here's the deal with this graph. This is considered a piecewise because there's 2 pieces to it, right? And it looks like there's something going on when x is equal to 4, there's not a value for y in the quadratic part of the piecewise. So there's a separate part. So when they ask us to find the value of the function when x equals 4, we're going to say, well, that is negative 6. Do I have to write that down? I don't think so. That would take a lot of effort. All right. For this one, this is a piecewise that would have 3 pieces, right? A linear piece, a quadratic piece, and then a dot. Just one value, a single point. Find f of negative 1. So if we're standing on the x-axis at negative 1, we would look up. We'd see that open circle says there's no value there. We'd look down and see that open circle, there's no value there. But we would also see this point right here, which indicates that when x is equal to negative 1, y is negative 4, which of course the y value is the value of the function. So you would say negative 4. All right. I think there's one more thing that was on Delta Math, and I'm not sure if I have this here. Oh, okay, let's do this, and then we'll talk about that one last thing. So it says graph the following function. Oops, I forgot to cover this up. So you see the question and the answer. So just make sure that this makes sense to you. Oh, I know why I included this. Some people ask me, what's going on with this 5, all right? What does that mean? Just a random dot? And sometimes it does mean a random dot, right? Like, if we go back, oh no, they're all covered up. Where's the random dot before? Like right here, when x equals just 5, the y value would be at negative 1. So that really is just a dot. That would be a dot or a point at 5 comma negative 1. But here, this is for not just when x is equal to a number, but when x equals a lot of numbers. So when x is greater than 3, y's value is always going to be 5. So another way to look at these two things, these piecewise, is that, see how it says f of x equals this and f of x equals that? Well, f of x is just y. So another way to look at the 5 is saying we're looking at y equals 5. And that's just that horizontal line, right here. That, of course, we have to have an open circle because when x is equal to 3, we don't have anything there. But when x is greater than 3, we've got the line y equals 5. So hopefully that helped. One thing, and I can use this graph to kind of talk about it. So once again, I'm going to take this graph and put it on the next page so you don't think that it's part of this problem. So let's just say we saw this random graph, and I know that I can type, can't I? Gosh darn it, this whole time I'm writing and I could have been typing. It's the end of the day. All right, sometimes in Delta Math you might see f of x equals, how about 1? Okay, and then it would say find x. Okay, that's saying, hey, when y is equal to 1, at what x does that happen? At what x does the function equal 1? So what you would do for these type of problems is you would just go ahead and look at the y-axis and you would look for the height of 1. And you'd say, okay, what x corresponds to the height of 1? On this graph, it is negative 1. So you would switch to your typing and you'd say x equals 1. All right, so we could do another one of those if they asked us, hey, what is, oh, let me look for another one. Wonder if they said, where is, oh, this is so teeny tiny. How about f of x equals negative 8? And then they're saying find x, find the place where the function equals negative 8. Well, we would just go ahead and look and see where's the height of negative 8. And we would say, okay, what does that correspond to as far as the x value? We'd say negative 4. So we would say when x is equal to negative 4, so when x is equal to negative 4, we know that the function has the value of negative 8. All right, so that was all the leftover stuff that you're going to need to succeed in Delta Math that I did not include in that first video. Thank you for being patient, and you all are doing a wonderful job. See you in class.